Hi everyone, this is Tom Cherryhomes with the FujiNet project, and I need to record a rather lengthy video today. So thankfully I'll be placing chapter markers all throughout the video here. But the idea here is for me to kind of do a rather lengthy video showing the network device, that is the end device on Atari systems, putting it into perspective and how it fits with the other devices that you may have on the system and the other devices that FujiNet provides. How all this is used in context. So with that, let's just get right into the video. To start with, when I'm talking about the end device, I'm talking about a device handler that is exposed by the FujiNet and loaded in using a special handler on the Atari, which loads as an end device, which exposes network functionality. When you have an Atari, there are certain devices that are built in, that have handlers built into the operating system ROM. These include the editor, which is the screen that you see here, the keyboard, the screen device too, which is used in certain cases along with the editor device, and you have a handler for the printer, and you also have one for the cassette port as well, for the cassette drive as well. When you take and load something in, say for example from FujiNet config, what you're actually doing is you're placing a disk image into a drive slot. And what you're typically loading or something like an ATR, which is a disk image. It's an assemblage of sectors that the Atari thinks it like the built-in ROM on the Atari can boot disk drives. There are routines in SIO to basically handle this. And there's just enough functionality in that to be able to load something into memory. And in this case, it would be a disk operating system such as MyDOS or AtariDOS, OSS-DOS XL, etc., or even our brand spanking new network operating system, which I will also be going over in this video. But for now, let's go ahead and just stick with, I'll just pick MyDOS because, and I'll mount it read-only into drive slot number 1. This puts it in drive D1, D1:D:. This is the drive handler. And again, when we boot this, the ROM inside the Atari has just enough smarts to talk to and send commands over SIO to the disk drive. And this is used to load a rather large handler into memory to handle the D: device. In technical parlance, this is what we call a file system because it provides a way to, the D device is a doorway into creating a file system on a disk, that is, ways to store and retrieve files off of a disk, to seek and find information within files on a disk, etc. All of that is handled by that D device. And because you have that D device, you can take and we can use the DOS utility package here. In this case, we'll just look at a directory. We can see that we have files here. We can take and load certain things into memory, and we can use them, etc., etc. The file system provides all the abstraction so that the Atari just basically says, okay, D device, open this file. D device, read from this file. Okay, I'm done with it. D device, close this file, etc. But one of the things that actually is on each of these DOS disks that you saw at the beginning of the video, each of these has a copy of the N handler inside of it. And it loads that handler automatically. What that handler actually provides is a new type of network device. So now we have this N device sitting here ready to be used. And because we haven't provided any path or any file specifications or anything, it's just sitting here going, well, error 165. Well, let's try to use it, for example. To show this, what I'm actually going to do is I'm going to go to a web server here called FujiNet Testing. And this is a web server that I have running publicly here. It's just a standard HTML document, nothing special here, but we have a series of files that are sitting on this web server that are all happen to be in Atari format. Well, what happens if we load one of them? We can. We go back. I will put this over here. And I will go ahead and do the following. And what we have here is essentially a URL. It's in Atari parlance, it's a device spec. And the device spec basically says, okay, give me a URL and I will take and convert this into something that the Atari can understand. We have here a protocol. We have a host name. And we have a path on top of that host name. There are a few other things that you can add to this, such as being able to specify a port number. Every protocol has a default port, so if you don't specify it, it will use it. And maybe if you were talking to a web service, you would want to do a GET query of some sort. Something like that. You can add those things, and all of those things are handled by what is called a protocol adapter inside of FujiNet. And I will go over, show and demonstrate a number of these protocol adapters so that you can see them in context. But what we're actually going to do here is we're going to take and load a copy of this game, Blackjack, directly off of a web server into the Atari. And there we go. So we can see that we've done that. And if we list, here it is. Boom. It loaded it in. BASIC was none the wiser. Sure. It worked. It's extremely transparent. And there we go. We've basically, through something that was never intended for an Atari 8-bit to do, because we've built this device handler in, and because there is a protocol adapter for HTTP and HTTPS, by the way, the Atari can talk to a web server. And if that web server actually happens to be, that the protocol adapter also happens to support WebDave. I don't have it configured on this particular host, but if you did, you could literally do a directory of it. In fact, let's go ahead and switch to another protocol adapter really quickly, just to show, just to prove the point. Let's go ahead and introduce another thing into the mix here. Right now, you see that I literally had to type out that URL specification entirely, longhand. Well, you can do what's called setting a prefix, and then there's two ways you can do this. You can either use the ncd command in DOS, which if you see here, we'll go ahead and boot out DOS, sure. And you can see there's a whole set of utilities here, and the one that we're interested in is called NCD. And NCD will literally take and place a network prefix. We'll load it in, And this is basically, you type this in and it will prepend this onto the beginning of your URL so you don't have to type it. You don't have to type it all over again. In this case, we're going to take and pass over to an FTP server. Sure, why not? But it's there. Now, watch what happens when I do a directory of n, because I've set that prefix. After a little bit of a wait, we actually see directory come back over through MyDOS. Sure. Well, now we can go a bit further, perhaps. If we do an n directory, we can actually see the long file names. But because we use the standard method of getting the dist directory through the n device, the FujiNet actually took and translated each of these file names into something that could be displayed as 8-character file name with a 3-character extension with an approximate number of sectors. And if the file name was longer than 8 characters, it uses the last 2 characters as a differentiating marker using a checksum so that each file name can be unique. There's a little bit of an algorithm where it tries to take and crunch the file name down, and all of that is handled on the FujiNet itself. So if we take and do a directory from where we are, because we have that prefix set, we'll see the same thing mostly with longer file names. And if a file name is longer than 31 characters, it will take and use another line to display it. It will keep adding as many lines as it needs to display the file name. You can see that that is as it comes from the FujiNet. The difference here is that we're setting aux2 to 128 so that we can get longer file names here. So there's that. We can continue to go up and down that file structure. We saw something for stuff. Sure, let's go there. And you can see us slowly starting to go through and find all the individual bits and pieces. Again, hold on, let me go back and we'll load in directory again. I'm doing all of this slowly and deliberately so you can see what I'm doing. If we go into, we have stuff, we have collections. If I go ahead and just do return, if I didn't put any path here again, now that we've prefixed here, now let's see, collections. Let's skip forward a little bit once we get past these next two bits and pieces. Let's see, in CD. We'll go to collections. And I'm sure some of you are thinking, okay, I can see some improvement to build a file manager. Please help us build one. All the bits and pieces are here. I'm showing you what we have to hopefully take and spark some innovation and discussion. So we go again. If we do an N directory here, we can see a long file name for a whole bunch of different things. And this one's kind of special because we have a lot of long file names here. And if we were to look at the same thing from the N directory, we will see each of these compressed up so that they can be resolved from MyDOS. So what I'm actually going to do now is skip forward a little bit using NCD, and we're going to go to Holmes CD, Holmes 2, Atari Archives, Antic Files 88. You can do that. You know where it is, bam, there it is. You can go straight to it. Now, if we do an in here, we see a lot of 8.3 file names that we can directly deal with. And yeah, you can take and use the copy command to copy them across, whatever. It doesn't really matter. We'll go ahead and I'll make a new disk here. And what I'm actually going to do is I'm going to use the fnew tool that's on drive 1 here to make a new disk inside of. So here we go. I want to put this on drive 2. I want to put this on my SD card slot. I want this to be a standard single density disk, and I'm just going to call it test disk. So now we've created a disk on drive 2 here, and you can see I've got separate sets of functions for drives, which are the ftools, and I've got which are the ftools, and then separate utilities for the end device, which are the end tools. And we'll get into the end tools in just a bit, but I want to show kind of a point here that if we wanted to take and copy something, for example, I happen to know that there's Sunset Basic there. Oops, let me actually take and, oops, sorry, excuse me. I can't hit the break key on this particular keyboard, so I'm just going to have to let that go. Let's do that. Let's see. Come on. Let me reboot. My bad. There will be a couple of glitches in the demos, folks, because I messed up, so I apologize for that. But you can see right here that we have, now that I've used the fnew command, we can see that this test disk is sitting here in drive 2. It hasn't been formatted, but it's sitting here, and that's what I need to do. So I'm going to go ahead and reboot. We're going to come back into MyDOS, and we're going to format this disk. And I just realized that my Altera was muted, so you couldn't hear the beeps and things. Oops. So you can see that we have a disk sitting here. It's blank. Let's go ahead and format it. And what we've done here, this is formatting a file system inside of that ATR disk image. And that's the fundamental difference between using the disk devices and the end device. The disk device can only deal with disks. It has to deal with files that are essentially big bundles of sectors. That's all it knows how to do. And the end device basically shows you a way to basically be able to break out of that. That's why this device is so important. Now we have this blank disk, and we can use, we'll go ahead and we'll NCD back because I had to do a cold start. We'll do that again. Stuff, collections, home CD, homes 2, Atari archives, Antic files 88. And again, if we take and go in and do a disk directory on that, we'll see it. And you can see what's actually happening here is it's going on to that FTP server. It's doing all the commands to talk to that FTP server and then serving back a something that the Atari can actually take and understand. The FujiNet has enough CPU power that it can take and do all that. So now we have this. Okay, great. We can see that there's a number of action files. We can see that there are a number of basic files. Let's take and copy something over. We can. So now that we've set the prefix, I can basically do this. So there's our Sunset Basic here. It took and copied that file directly, transparently over. And as you saw before, we don't even have to do that because Basic can literally run that program directly. I could have just typed run. So, I mean, there you go. All of this is happening transparently, and it can happen transparently because we have this handler in memory that's added this other device that talks the same commands that devices like the D device actually take and provide. So, and as you can see, depending on the DOS that you use, you have a certain amount of integration that is directly possible. You can see that I'm using the directory commands from BASIC, whatever. It doesn't care. It will take and happily take and deal with that. Will happily take and deal with that device. And this extends well beyond BASIC. For example, I can just as easily turn right back around. We'll go ahead and set NCD real quick. Actually, we'll stay right here on this FTP server. I'm going to take and go ahead and attach a cartridge. Copy of action. We still have these 2 disks sitting in the folder here, but I'm going to go ahead and just hit the Option key. Let action boot right up. I'm actually kind of wondering, oh, I cold started, so I'm going to have to go back into DOS here. So let's go into the monitor real quick. We'll go out to DOS, and we'll set that path again. Because of how Altera works and because the cold starts will cause FujiNet to reset, I lost my prefix. So I have to put it back. If you have your FujiNet connected and powered on, it will keep that prefix until you reset it. So I'll make sure that this is correct. Okay, great. Boom. Oops, sorry. Hit the wrong key. Hit the backspace key by accident. And we'll do an A of N just to make sure we're in the right place. Okay, great. Looks good. So there we go. We will go back to the cartridge here, and I will use the read function. And there is a copy of frog act in that directory there. I will just load it directly in. And I can do this again because I've set the prefix. And here we go. Here's that game loaded directly. Here's the source code for that game loaded directly from that FTP server, directly onto the Atari here through the FTP protocol adapter. And it works. I can take and go back into the monitor. I can compile this really quickly. And I can run it. There it is. It's all pretty much there. And you can take this, you can take this even further. I'll keep the action cartridge in place. I will go back out to DOS, and I will set a new prefix over to my file server, just because I can. Or actually, let's throw something else into the mix here, because I'm feeling adventurous. I have, among other things, a network file server that I can go directly to, Windows file server, using SMB over here. over at errata.online and public here. Okay, there it is. This is actually, even though it runs on my public file server here, it's actually walled off from the public and is only accessible through my internal network here. But this is a simple little Windows file share sitting right here on the network using the SMB protocol. Can I access it? Yeah. Again, using the same tool here. And I will say SMB. So now, when I look at this, you can now see much the same thing. Okay, great. But now we're looking at a Windows file server right here. You can see. So I'm actually going to take, we have in pointing to a Windows file server here. Of course, you can use the copy command, but you don't have to, because I can literally take and run ncd again. And I want to point out, at this particular point, you have 8 network devices that are exposed by the FujiNet, SIO devices 71 through 78. And these are exposed via the handler as N1 through N8. So you can, while we have N1 set up over here to be my SMB file server, I can just as easily go back over here and point N2 over here. So if I do N2, okay, looks like, all right, we have a slight bug here that needs a little bit of work. Okay, darn. Well, that's what's supposed to happen. Pardon me for a moment. Apologies for that. There were going to be a glitch or two in this demo, folks. I'll do this a little bit differently. So if I go ahead and set the NCD to my public, so to my private Windows file server here, we can see that we're here. Bam. Okay. There we go. We have that. I'll go ahead and we'll just do. There we go. A quick little program here. We'll go ahead and save that. Sorry, not. Nope. W. We can just as easily take and save that. So there we see it immediately showing up already over here on the Windows file share right here automatically. Take it, turn it right back around, take and compile it. Run it to the monitor, compile it, sure, run it. There we go. So you can see right there the possibilities for having a local file store here that you can turn right around and do implementations in and do fast turnaround, basically between, say, an emulated Atari and a real Atari, using the network in the middle as a potential for potential use. Now, let's take and throw some more bits and pieces into the mix here. Right now, these files, that file that we just created, actually is in a TASCII format. It's in Atari's native line ending format. And if we were to take and have a little look at it, I'll take and pop open a new window, a new terminal here. Just kind of place it, okay, something like that. And we were to take a look at what got put up over here. I'm actually going to have to go over to that server real quick. Pardon me while I type my password correctly. And you can see right here, we got the test server that we were using earlier here. But we have our hello act that we saved over here on this file server. And if we were to take a look at it, we would basically see, okay, wow, it actually did save it. Yeah, it's in Atari format. So if we turn right back around and we use another tool here called NTRANS to set the translation mode. Right here. Which in device? In. And we're going to take and set that to output line feeds for line feed mode for Unix. So we have Unix style line feeds, but you can also set CRLF, which is what Windows uses, and CR, which is what ancient Mac uses. You have all three of those options. So if we now take and turn right back around, go right back in here, I will change, come on, here we go. And do that, write that out. This got translated. We'll see hello 2 act here. And you can see right there, bam, this became an ASCII file with line endings here. Well, let's modify it. Use any basic text editor, doesn't matter. Bam, save it. It's there. It made a backup file, but I'll just delete that. Boom. We will take and clear this out. Let's see. Trying to remember how to do this. Shift clear. It's been a while since I did this. So anyway, hold on a split second. Doing this on a PC keyboard is interesting, to say the least. Where is input? Yeah, here we go. None. Well, let me do my arrow. It's not letting me do my arrow keys. Ah, darn it. That's okay. We will take and just do a basic cold reset with the computer only. Basically hitting a point where I can't hit certain keys on this keyboard. Sorry about that, folks. Because I'm doing a cold reset here, it's kept my prefix, and we should just go right back into the editor. I'll take that, we'll read. And now we can see that we took and did a modification using our favorite text editor over here on the PC and brought it back in, and the FujiNet took and translated the line endings, etc., so that Action would be just fine with reading it. We can go out of the monitor, we can compile this, and we can run it. And there it is. So the possibilities there, hopefully, are becoming more apparent here. So we can translate back and forth. We can do all these different things. When we're done with this particular thing, we have to remember to take and set the translation back to binary so we can do normal stuff again. So here we go. We load NTRANS again and set that to none. Now we're back here. So everything I've shown you right here, we've shown you a couple of different protocol adapters: FTP, HTTP, and the Windows SMB. And in each case, I didn't change anything about how I was accessing these individual files. They're all accessed in exactly the same manner. This is important because it provides a wonderful set of device abstraction as we take and add newer protocols, NFS, Google Drive, whatever. You will be able to access them in exactly the same fashion. So moving forward, this device independence, I've shown you it from running from Action. I've shown you it running from using it from DOS. I've shown you it using from BASIC. But anything that actually can handle CIO, will be able to use this. And because you have the ability to set the device prefix, if you have to provide the full path to a given file name, because a program will assume anything that's not a D device will accept a file name, you can set the whole path to a given file name and it will still work. Case in point, we'll actually do this in two different ways here. I will take and go and set the prefix back to our good old web server testing here, FujiNet testing. And actually, I'm going to have to do this again because I realized I'm going to insert a cartridge, which means it obviously wants me to turn everything off. I just realized I have to do this again, but that's okay. So let's go ahead and go into Music Composer, because why not? Who would pick Music Composer of all things? Oh, I did. So there. You can see that we have a Music Composer file here as one of the tests. We'll take and go right back out again. And for this, I'll pick a totally different operating system here that we'll take and transition into. We'll take and show that this works pretty much everywhere, regardless of which. So let's take and go over to, let me set my input again. For some reason, my arrow keys are no longer mapped. Go back into our DOS folder. And again, I have to remind you that every one of these DOSes that are in this folder all have the N handler put onto them, so you can use them. Let's just to be different, I'll use Atari DOS 3, because why not? You can see that we've booted into the Music Composer cartridge here. And if we go to DOS, we'll wind up in the DOS 3 menu. And DOS 3, each of these are implemented as user-defined commands. So you can load each of these particular files using the external command here. X user-defined ncd. And you can see it working right here. Okay. We'll go ahead and come back out here. FujiNet testing, errata online. Bam, boom. And then we go and back to the cartridge. We will retrieve the music here. The file name is foo.music. We'll grab everything. You can see right there, it loaded that pretty quickly because this is a very simple little musical tool here. And we'll just listen. So you can see right there, the music composer was able to take and load that particular composition using the HTTP adapter directly off the web server. It's, again, none the wiser. You're going to hear me say this over and over again, but this is the power of having this CIO handler in place. But what if you have something that can't handle long file names, can't handle any file names for anything other than the D devices? What can you do? Well, a couple things you can do. Well, and I chose DOS 3 for a good reason here, to basically pull this point across. We'll go ahead and we will, to prove a point, the N handler is loaded into memory, and we are going to try to do the copy and append command, which is external in DOS 3, to copy foo music over to drive 2. Source device in. And you can see right there, it's beeping at me because the copy utility is basically, at the time the copy utility was written here, they were never thinking, oh, well, the only thing that can handle a device is the disk device here. So if I take and put that, okay, it's not going to let me type anything here. You're going to see that this is like, yeah, no, not going to happen. Okay, great. So we'll come back out and we will use the ncd command to set a full path. And since we're already there, I will literally just do this. And it has basically put foo music on the end of it here. Actually, I need to do that again. So let me go ahead. Not load, but excuse me. I did that a little wrong. Excuse me. We'll do it again. Unit testing errata.online / foo music. And actually, I need to format the disk so that it will work in DOS 3. We'll go ahead, since we have that work disk that we put in earlier, we'll just go ahead and use it. Yeah. Am I improvising? Just a little bit. Now we have this disk. Let's go ahead. We can see that we go D2. It's, yeah, there we go. Let's go ahead and run the copy append. And we can see that we took and copied that file. But we used the ncd command to basically work around the fact that utility had no concept that it could that something other than the D device could have a file name. So we could take and basically bounce across. These are the types of things that you can do, which kind of brings us to another point here. So if we have a situation where we have a file system that can't support reading and writing to from the disk, whatever, we have the N utilities that we can use to take and help us along. And actually, before I do that, I'm going to take and make one other point here. If you use if you use these tools with a operating system that supports command lines, it will take and adapt to them appropriately. So let's go ahead and we'll do a cold reset of everything here, and we will go into SpartaDOS here. So we will go into apps, we'll go into Atari 8-bit, we will go into DOS, and I will pick SpartaDOS 3.2, because why the hell not? And I still have the music composer sitting in the drive here, which is kind of funny, but sitting in the cartridge bay, which is kind of funny, but we'll go into it and then bounce back out again. Ah, boy. So there we go. Of course, we can see. Come on, there we go. And again, just like every other DOS disk, we have a copy of all the utilities here that we can use and that are at our disposal. Now, if I take and use NCD, that means I can basically do something like this. Set the command directly there. And if I do npwd to print the working directory, we can see that that's our new prefix. Now, since I'm in SpartaDOS 3.2, I can actually do this. And you can see right here that we are now looking at the networked resources here. Now, the things we run into more have to do with limitations in the file, in the disk utility package than anything else, because the disk utility packages of these different operating systems all make some basic assumptions, like file names are 8 characters wide by 3 characters long. But as we've seen through the end device here, we've kind of smashed right past that. We can have long file names, and BASIC doesn't care, because all BASIC does is it just it calls CIO and asks for the file, and it gets it back, no problem. But these various disk utility packages can have their own assumptions and their own little landmines and things that you can run into. But all the same, it essentially does mean that you have direct access to a bunch of stuff. Oh, look at that. Go look at our SMB. Oh, drive. There we go. And so on, and so on, and so on. So you have access to all of these things. And there are all sorts of other little utilities and things that you can run. So let's say, for example, in MK directory, I want to make a directory on drive in now that I've set the prefix and call it foo. Okay, now that I've done that, I go back. Oh, and FujiNet has crashed. Pardon me. There seems to be an issue there. I will have to resolve. Let me pause this for a moment. Apologies for that. There's another bug I need to fix in FujiNet PC, but we'll get it. It's in the SMB protocol adapter. But if we go now that we've done the NCD, if we go here and take a look, we can now basically see, or not. Okay, so there's a bug in directory creation on for the SMB protocol adapter. Let's go ahead and go here then. Sorry, copy, yeah. Go here. Try this again. We'll make a directory called foo. And we go here. We'll see that there's our directory ready to go. And I can go right into it. So sorry. CD. And we'll go foo. Sure. There's our directory right there, and we can just make and create things to our heart's content. There we go. And so on. And actually bringing that to text, this actually brings up something else definitely worth taking a look at. The HTTP adapter actually implements pretty much all of the HTTP standards. This includes get, put, post, etc. So you can write applications that talk to web services, but you can also talk to web servers that have WebDAV enabled, WebDAV, which gives you file system-like functions. So you can do things like edit files on your web server directly from your Atari computer. And that's easy enough. What we have to do is basically point it to our good old friend, the testing page here. We see the FujiNet test server right here. And this is an index.html page that we can actually modify because I have appropriate permissions. So if I take and set ncd, go back to drive. If I set ncd to, actually, let me do this a little bit differently. I need to insert a cartridge in just a moment. I'm wondering how I'm going to be able to do this. I can do it from my Atari here, because every time that I take and bounce this, it will cold start my Atari. Oh, it will cold start my Altera. So let's do this a little bit differently. Okay, I'm thinking on the fly here, folks. So we'll take and switch over from my screen capture device to my Atari here. And this actually is a little bit of a detour here, because as we've seen before, we can load basic programs. And we can see that we have right here a fairly basic little terminal program that uses the end device. It opens a connection to the network device for a TELNET endpoint. It opens a keyboard and then just goes into a loop where it scans the keyboard. And if it finds something, it spits it out. And if it receives something, it figures out how many bytes are waiting and then grabs that information and displays it. It's a simple little terminal emulator in about 1, 2, 3, 4, 5, 6 lines of code. And as we can see right here, I mean, it works. Using the same end device. And we can do this precisely because Atari, for any CIO devices, it treats all CIO devices, the D device, the R device, C device, E device, S device, etc., all as character devices. So they all work exactly the same way. So here, all I did is change the endpoint to have it behave completely differently. And so if I were to take and change this, I will change this to read. I'll take and flip back over to my screen capture for a moment to read my GPL 3.0 here. And yes, once again, I am improvising. So we'll get this working here. So all I've done is change the endpoint so that it reads from this particular file off of this particular server right here. And we're doing so with actually one little change here. I'm going to make it use standard line feeds. And these are the same numbers that you use for NTRANS here. So there you go. Boom. GPL 3.0. Okay, fine. The keyboard's not going to be used, but it's going to show you that with a small tweak, or not, Or not. Maybe not. All right. Maybe I was pushing it a little bit too far. We'll grab it from the web server then. And actually, we'll throw another. We'll do that. We'll see if this works. Here, let's just do that. So there we go. It's translating the line endings for us, and with one little change here with the endpoint, we're now reading a document off of a web server directly in to a basic program so that we can process it. And it works. Minimum changes. Now, before we did this little side step here, where were we? What were we going to do? Oh yes, Atari Writer. Well, can I? Do I have my flash cartridge? Actually, no, I do not. So I will take and flip back and do this using the action editor then, I guess. Alright guys, yes, I'm bouncing all over the place, just improvising. But you can see with a little bit of improvisation, some things start to open up. Let's go back over here to my emulator setup. Bang, boom. Okay, so there we go. Back here, we are where we were. And I will take and put in my action cartridge again. And we'll have SpartaDOS running in the background. Actually, let's go ahead and while we're doing this, let's see. I'll use the standard Atari writer here. And yeah. Oh, this gets interesting, don't it? So we bypassed our Atari writer cartridge here just for a moment. Here we are here. Okay, well, that's fine. Actually, action, sorry. I need to be able to get out to DOS. It amazes me that they didn't have a way to actually get out to DOS. So I'll use the action cartridge instead, because I literally can't swap out here. It's the only reason. But I've done this demonstration with Atari Writer many times before. So, action. Action is a lot nicer for the system, OS-wise. So for this, I'm actually going to take and we'll flip over to another operating system entirely. You might be asking, if you have the ability to have these network protocols and to read and write to them and handle things much like a file system, do you need the D device at all? And the answer is no, you don't. You can literally take and use an OS here and boot directly into that. And what this actually does is it loads the N handler all by itself. There is no D. And in fact, D actually is an alias for N within OS. It just uses the N handler. It loads up pretty quickly. And then now we can basically take and go to the monitor, go to the DOS prompt, and we find ourselves directly at an N prompt. If we don't do anything, nothing is set, so we literally have to take and set a prefix like we always have so we can get something useful. In our case, we will literally take and set UGNet testing errata.online. Bam. Okay? From that point, we can then take We'll use the help command to show some of the other bits and pieces that are available. Help NOS here, for example. And we can see that many of the same commands for the end commands have been implemented here. In CD and PWD, we have delete, rename, etc. But all of these things work on network resources instead of anything on the disk. The only thing a disk is used for is to boot the NOS into place. And in fact, if we try to do that, you're going to find that it's kind of useless. There's nothing there. So we'll use NTRANS, and we'll set NTRANS for this particular path to be line feed for Unix. Okay, great. Well, now we can go back to the cartridge. We can go back into the editor, and we can read index.htm. And in a few moments, let's see. Sorry, let me do that again. So there we go. Now not found. Did I call it index.htm? Let me look real quick. I apologize, folks. I'm literally doing this on the fly. So let me reread this. Let's see. So let me go back in. Okay. I cannot remember how to clear. I literally cannot remember how to clear the oh, come on. 1 second here, folks. Again, let me just get resituated. I apologize, folks. This video is getting a little long. I had to take and abort that because we're going to have to see what's actually happening here. So there's a regression that has popped into the firmware and is preventing the action editor from editing the web server documents. You've seen me take and demonstrate this before, and if you want to see it again, I will take and put a link in the description. While this video is getting a little long, we'll take and basically finish off with the end tools, what they are, and ultimately why you would need to use them. Initially, the end tools came about because there came situations where certain operating systems couldn't use the end handler inside their disk utility package. This is an example here. Atari DOS 2.0 is a good example of this. Apology. We'll take and boot into it. And we'll see that even though, oh boy, this is getting very annoying, waiting for it, let me clear out my notifications. Even though the end handler loaded, it's part of the auto run sys and it's in memory here, the disk utility package has basically clobbered it. So if I try to take and use it, we will find that things error out pretty much immediately and things go south. And that's literally because the disk utility package has completely clobbered over the end device handler itself. But if we take and boot in to basic, we'll actually find and see that it's actually just fine. Or to boot. And it seems that my Ultimate 1MB emulation here has clobbered over Uh-huh. There we go. Hello. Hi. We'll see that even though the disk utility package can't use it, DOS2 can actually use it just fine. You can see, okay, it works just great. It loaded that fine. It just gets clobbered on the way out to DOS2. So the end utilities were basically conceived as a way to basically work around that. And they consist of a set of intuitive functions for all the things that you would need to do file system things with the end device on. These include NCD for changing the directory prefix. Again, if you've seen me use time and time again. Let's just do this. Nice thing about this is that these actually load it high enough up away from the disk utility package that when they do an RTS, they just go straight back out into DOS2. So they work fine in this regard. So I can do that. I can do an end directory, as you've seen me do before, out to my Windows file share. I can make directories, I can remove directories, I can go into them, etc. But I can also do things like copy. For that, we'll take and format that test disk that we have here. Sure. And we'll use ncopy to copy a copy of hello act over to drive 2. So even if you can't access the end device due to your disk utility package not working like it's supposed to, or things get clobbered, you still have the end utilities to basically take and work around that fact if you need them. And yes, ncopy does support wildcards. So if I do ncopy and then because I have that prefix set, I'll take and copy those over. Bam. Or not. Man, this is literally proving to be yes, and that's what happened. Okay, we seem to have an issue with the SMB adapter that I need to take and resolve. Darn it. That sucks so bad. No. Okay, so basically FujiNet has crashed here over here with FujiNet PC. There's an issue that needs to be dealt with. But yes, suffice it to say, yes, ncopy does work. I will use the TNFS adapter instead. Do that. Go ahead, boot in, same thing. So, back again. And NCD. And we will go into TNFS TMA-2. And you'll notice here, the big difference, and I'm going to point this out again, I've kind of alluded to it, but I'll explicitly point it out here. When I use the TNFS adapter in the end device, this is accessing the TNFS server on a file-by-file basis instead of a disk image by disk image basis. I hope that makes sense. So we've got that. Let me go ahead and see what we have in our TNFS directory that we could probably take and pull over here. I'll just, I'll get rid of this because I don't need it. Boop. Yeah, that's fine. And we will take and load ncopy. Let's see. NPWD, see what our prefix is. Okay, that's good. So in copy, I'll take and copy everything over to drive 2. There seems to be, okay, there is an issue happening here with, okay, FujiNet PC that we need to resolve. I will do this over on the real Atari then. One moment. Okay, let's try this again. So back over here at the real Atari, and I've booted up into DOS 2 and have the test disk over in drive 2. We basically just need to go ahead and format it. We can do that with standard command. Sure, why not? There you go. So there's that. But we can also use XIO commands for other things too, such as setting our network prefix for our end device. So there we go. If we do a directory on in, now we can see it. Boom, there we go. We're good to go there. Okay, great. So there's our DOS. Now, work in drive 2, nice and empty. Okay. We can't use the in tools inside of the disk utility package, so we've got our prefix set already, so we can just in copy. And we'll copy those 2 files over to drive 2. So yeah, you can see that even wildcards work. And you'll notice that that was a long beep right there. So it literally took that whole file as one solid block and bounced it into memory, so resulting in a faster copy. So we can do that because we can bypass all the blocking and deblocking that has to happen in CIO and just handle things directly. That's another advantage of the N tools. So basically from both sides, you have this in device that provides a whole host of file system-like functions and device-like functions for the in device, for any program that can do CIO input and output. You get the in utilities, which talk to the network device directly if you run into a situation where you can't use the end device. And these things all come together, and you can write whole new applications that use the end device to take and communicate with network resources using all the same calls here. So this translates out into a very powerful device. So with that said, where does that leave us? Well, as you can see, there were a few glitches that happened during the course of this particular video. These are glitches that we could definitely use help in improving, both in terms of the Atari side of the tools to make them work better, but also in terms of firmware to take and debug as we work through and find edge cases of things that we need to deal with, such as reading and writing files from a web server using the action editor, figuring out why these things happen, how these things happen, and improving the overall user experience here. Now that I've shown you a big picture of what's possible with this network device, I hope that it can get the gears turning. And I'm calling out for everybody who wants to be able to hack on this. If you have an idea of something that you can make with this, come to us and help us make this happen. I'll put a link to the Discord in the description. So you have all these things that come together, and ultimately, this is a whole new frontier, and I'm really trying to swing home as to what is possible with this particular device. And I hope this video that I put together really drives that home. So, as always, until next time, guys, have fun.